Hi, this is PhD Albros at Rafshar. I'm going to dice another force. I didn't get to comb my hair. I'm going to dice another force right now. These are the dice in the box. So I'm going to count to 43. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. Okay. ILI, apparently. ILI. So I is current, 2 times current apparently. L is length of wire. So you had laws associating with IR squared. IR was V. So length of wire was associated with resistance. So you can use that. Power was, I think, IR squared. And I think the force was, at that point, forces were V associates with forces through E is FEC, F is EQ, electromagnetic field times charge. So E associates with charge through with not as charge but V through X, which can be the L here. So EX was, I think, V, or E per X was V. So you can use the L that way, and then you get to V, and V is associated with I current, so V is IR. Now I need 2 I's apparently. I can, for instance, split up the 2 currents. The force can be split up in 2 currents, the opposite direction currents. So I can use the I as in root I1 and root I2. I think I did that once, but if you say that the current was associated with that, so I'm going to draw this right now, which I say root I1 and root I2 if there's 2 opposite direction currents, or same direction currents. If the currents are stronger, you have stronger force. So I'm going to split up the IR into root I1 times root I2, okay, times R. At that point you get, that is the V, okay, and that would be then you put that into the E for the force, and E per L, or E times L for the force, times charge Q. And at that point, I think once the currents are stronger, start getting, since it's 2 currents, you start getting stronger forces if each of these currents is in opposite direction or the same direction stronger. Okay, so I'm going to write that down also as I thought of that force. That's it. So I can also put a second L for the resistance. The resistance increases with the length also of the wire. With the surface it decreases, which was also a formula. I can use that too for the R. For instance, I can use the length that way twice. I think power was R squared times I, so I can use one of the power terms, and then that could be power per power times time times per distance. So divided by velocity, I think, is also the force. I can use that one too, also as a type of force. So if I do I r squared at that point, so I'm going to look these formulas up in the books and get them exact, and I'm going to write them down too. Okay, that's it. So that's I L I. Okay, so that's that then. Okay. And this is the video of it. That's it.